Less than 2 months after launching the first flight of a Starship version 3 rocket, SpaceX is preparing to run it back with Flight 13. Superstitions about the mission number aside, SpaceX is hoping to accomplish big feats with this next integrated test flight. SpaceX President and Chief Operating Officer Gwen Shotwell forecasting the anticipated cadence for the company during a conversation with CNBC back in June.
What is it, beginning of June? Maybe a month-ish away from Flight 13.
Okay.
And then we should fly every month.
So we could actually see a Starship that is in operation by the end of this year.
Oh, in orbit?
Yeah.
Oh, yes.
But to get to the highly anticipated orbital flights of Starship, SpaceX needs to improve the reliability of both the Super Heavy booster and the ship upper stage. About 1 minute and 42 seconds into the ascent during Flight 12, one of the 33 Raptor engines was shown out on Booster 19.
Each separation.
Less than a minute later, during hot staging, an issue prevented a nominal boost back burn, stopping the Super Heavy booster from reaching its target splashdown zone in the Gulf. SpaceX pointed the blame at the engine startup sequence on the ship upper stage, which it said, quote, caused the directional flip of the booster to be off by approximately 90 degrees. Additionally, SpaceX said of the booster during its boost back burn, quote, 5 of its 33 engines experienced issues when attempting to relight, causing the boost back burn to end early.
Yes, sir. Can confirm exec team is aware that booster did not make it to the final landing location.
The Super Heavy on this upcoming flight has hardware modifications to improve relight reliability, along with updates to engine alarms and aborts to match the conditions seen in the multi-engine flight environment. Those upgrades received a good shakedown during a 33-engine static fire test on July 10th. As for the ship upper stage, during Flight 12 in May, visualized telemetry data showed one of the Raptor vacuum engines go out around 3 minutes into the mission.
And we just see one of the RVAC, so we're now running on 5 engines on ship. We do have engine out capability, so it's going to continue into its ascent.
The plan was to have engine cutoff happen a little more than 8 minutes into the flight, but as they say about best laid plans.
Again, we did run longer as we were engine out. We were flying with 5 of those 6 Raptors pretty much the whole time. All right, well, we definitely got a ship in space right now.
SpaceX addressed the RVAC engine out in its pre-flight write-up on Flight 13. However, like with the 5 sea-level Raptors that ran into issues, SpaceX did not elaborate on the root cause of the Raptor vacuum engine issue. Several hardware and operational modifications have been made to address the interconnected causes, with additional reliability improvements planned in upcoming versions of the Raptor engine, SpaceX wrote. SpaceX was hoping to perform a relight of one of the Raptor engines during the coast phase.
The relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
That was set to happen around 38.5 minutes into the flight. However,
we're going to be skipping that relight of the Raptor engine, just due to everything that we saw on the way uphill. Those sea-level engines, we're going to use them for a landing burn, though. They are still capable to be used for that. So we'll still look to do a controlled landing in the Gulf, but no in-space relight.
SpaceX has been able to perform an engine relight during previous missions with version 2 of its rocket. They will attempt it once again with the version 3 design to prove that Starship can safely deorbit on future orbital missions. SpaceX demonstrated a single engine static fire in late June while Ship 40 was at the Massey's testing site. Shotwell told CNBC that it's one of the keys to unlocking orbital missions.
When do we get to full reusability? When do we get to orbital flights for Starship?
So it largely depends on the FAA, actually. We have done an in-space Raptor lighting, so we feel pretty comfortable, but we want another suborbital shot on the next flight. And then I hope we at least attempt an orbital injection on Flight 14, and then from there on out.
One of the big accomplishments of Flight 12 was deploying nearly 24 Starlink simulators from the so-called PEZ dispenser on Ship 39. There were also 2 tech demo satellites designed to capture imagery of Starship during its coast phase.
So these 2 satellites will be just 2 of 22 total deployed objects. The other 20 are what we call satellite simulators. They don't have computers on board or anything like that. They're really just hunks of steel that mimic the shape and weight of satellites approximately. It helps us test the PEZ deploy system. We're also going to be inspecting the more sensitive components of the satellite, the laser optics that send data to other satellites, the thruster on board for on-orbit maneuvering. All of those systems are more sensitive to things like FOD or dust. So we want to give them one last inspection before they go in to make sure they're ready to go to space.
Flight 13 will further up the ante, with SpaceX set to deploy 20 real Starlink version 3 satellites. As part of this initial test, Starship plans to deploy 20 satellites, which will extend solar arrays and antennas and will attempt to connect with the larger Starlink constellation via high-capacity lasers, SpaceX wrote. The Starlink satellites will be on the same suborbital trajectory as Starship and are expected to demise upon re-entry approximately 20 minutes after deployment. SpaceX said 6 of them will also feature a camera suite to capture imagery of Starship, similar to Flight 12. Several buoys will also be deployed again to capture video of Starship's splashdown in the Indian Ocean. SpaceX is testing a number of heat shield-related updates on this flight as it continues aiming for a fully reusable upper stage. Multiple tiles will be attached to the metallic side of Starship's aft flaps, along with modified tiles and attachment mechanisms in the heat shield covering the aft skirt to gather flight data on different attachment options, SpaceX wrote. Starship's heat shield will have load-sensing tiles to take measurements as the vehicle experiences higher dynamic pressure on ascent than previous flights, putting added stress on the tile attachments in exchange for increased payload-to-orbit capability. It's unclear whether NASA Administrator Jared Isaacman will make another trip to Starbase himself for this flight, but NASA is closely watching this mission. A version of Starship V3 with a docking adapter is set to rendezvous with the agency's Orion capsule during next year's Artemis 3 mission. Human Landing System Program Manager Steve Creech says these development flights are critical for the redesigned Artemis 3 mission in low Earth orbit.
Having multiple flight tests so that they can learn and refine their design, and so we'll be watching how that matures, how that progresses to be able to fly at the kind of rate and reliability and to execute these missions for NASA.
Flight 13 is also the company's first Starship mission as a publicly traded company. A large chunk of SpaceX's stated goals run through an operational Starship. Those include deploying Starlink version 3 satellites into orbit and eventually its artificial intelligence satellites called AI-1. On the road to launch, SpaceX completed a 6-engine full-duration static fire of Ship 40 on July 2nd. The final big pre-launch test came just over a week later on July 10th. A full-duration static fire on Booster 20. SpaceX founder Elon Musk said Wednesday morning that a launch Thursday evening was still in play. But as always, weather conditions and the unknown unknowns will have the final say over when Starship Flight 13 takes place. Reporting for Spaceflight Now, I'm Will Robinson Smith.